Hi, I'm going to go ahead and talk about our lesson 11 for Karen and Jason. And I'm going to go over part 2 of our homework. So, alright, so part 2 of lesson 11, we're talking about, at this point, we don't have sigma. It's unknown. I guess it's always been unknown, but right now it's unknown. We don't have it. Okay. So part 2, it says a study by the National Association of Realtors reported in 2004 that the second home sales accounted for more than a third of residential real estate transactions. According to the report, the average age of a person buying a second home as an investment rental property was 47 years old. A real estate agent wants to estimate the average age of those buying investment properties in his area. He randomly selects 15 of his clients who purchase an investment property and obtains the data shown, which is all the different ages within his clients. And so I'm going to get, the question is, what are the requirements for creating a 95% confidence t-interval? Okay, so the first one is that it is a random sample from a population, which from this one he's randomly selecting 15 of his clients. And then the second is the x's, which is the x bars, are normally distributed. Okay. Question number 2. With the data above, create a 95% confidence interval to estimate the mean age of all clients who buy an investment property. Input the numbers that we received from number 7 from part 1 into the confidence interval formula. Go ahead and show our work below. Okay, so with these, I had a bit of a stumbling block because when I calculated it, we have to put 0 under, I have my notes. We have to put 0 in one of the, I think it's the test, and it shows that we have to keep it at 0 because we're doing this. And then it'll just go to 95 because this question is for 95% confidence. So then it goes to 95 and it gives us our 41.8 and 51.6. And that's using the SSPS software. And the way that we do that is we go to our analysis. Sorry, I'm just looking at my notes here so that I can do the right order. We go to the analysis and then compare means, and then the sample, I think it's a test value, and then we input some more of the other data. For number 3, it says now create a 99% confidence interval to estimate the mean age of all clients who built an investment property. And then it gives us the t-distribution with 14 degrees of freedom. The 14 degrees of freedom with 14 degrees of freedom is 2.9768, and so then the corresponding for that would be 39.9 and 53.5. Again, with this one I had a bit of a stumbling block because when I was entering my data, I was off by like 1. I'm not exactly sure how I came for that, but I was off by 1. So I have to figure that out, what I'm inputting. Then for number 4, it's now using the software again, SPSS, compute the 95% confidence interval, again with the same data. So it's the same answer for number 2 is the same answer for 4A, which is 41.8 and 51.6. And 4B, the 99% confidence interval using the data above, again 39.9, 53.5. And then how does the margin of error of the 95% confidence interval compare to the 99% interval? Well, the margin of error of the confidence interval, it gets smaller. It's getting there's less of a difference in the confidence level than the 99% confidence level. Okay. 6. Rather than estimating the age of his clients that buy investment properties, a realtor agent would like to test a claim that the age of his clients is different than the national average of 47. So use the 0.05, which is the significance, I believe. That's the our sigma as your level of significance. Yeah, I'm sorry. Follow the following sequence of steps. Fill in your answers at each step and show all your work. Okay, so it wants to know, state the null and alternative hypothesis. So this is where we put the null would be the HO colon mean, which is 47, because that's the age they're starting with. And then the alternative would be HA mean, and then the equals with the cross, 47. The null would be the first one. And that would be like the, if I understand correctly, the single tail. And the alternative would be the double tail. Okay. B, this is for 6B. Compute the test statistic. First, compute it using the formula shown in your work below, then check this test statistic by inputting the data into the software. Okay, so this is where we have yet another formula, which is great because I like being able to put in the numbers and figure it out and be able to refigure the formula for different steps. So that's great. So for T, the formula is the x bar minus the mean over let me just look up our symbols here. The S is a sample standard deviation over the N, over the sample, which is a 15. So for here, the number that we calculated was 46.73, which is our X bar. And then our sample population mean is 47 over our sample standard deviation, which is 8.83. These are the numbers that we got in number 7 of part 1. Okay, and then that's divided by the root of 15, which is a sample of how many of his clients. So then it equals, the T equals negative 0.118. Okay, and then C for this question is state the degrees of freedom, which the degrees of freedom with 14, which were also given that information up above. D, sketch the T distribution and shade the area which represents the p-value. And so that sketch shows the tails. Again, we had a bit of a clue up above. So with the software, it says compute the p-value. And the p-value comes out to 0.9077. And you have to be really careful when we're displaying the numbers and where we think, oh, let's cut it off at number, 3 decimals or 4 decimals or 2. We have to make sure that we don't calculate any of these figures until the very end, that we don't round up or down until it asks at the very end, because it does throw off the numbers a little bit. Not a lot, but a little bit. State your decision. This is F. State your decision. Do you reject the null hypothesis or fail to reject the 0.05, again, significance level? So because p-value is 0.907, which is greater than 0.05, and according to the way that works, according to that formula, is that if the p-value is greater than the sigma, than the 0.05, then we fail to reject the null hypothesis. Alright, G. Present your conclusion in an English sentence relating the result to the context of the problem. Well, here we don't have enough evidence to, with certainty, that the mean age of the realtor's clients, or by the second homes, are different than the natural, than the normal average. So we have that. All right. Thank you.